Welcome. This is another IXL support video. We're focused on cluster Y right now, the linear equations cluster, and this video is going to focus specifically on Y.6, the assignment that's called graph a line from an equation in slope-intercept form. So as this assignment loads up, if we're going to be making a graph and the equation is in slope-intercept form, we need to understand slope-intercept form. Slope-intercept form, as hopefully you recall by now from the other IXL assignments, is any linear equation in this y equals form. If it's built in the y equals form for a linear equation, the m, whatever number multiplies with x, represents my slope, and the b, the number that's added or subtracted all by itself, the number that is not multiplied with x, that's my starting point. That represents the y-intercept. Also important to understand, a slope is really going to tell us the rate of change. It's going to tell us how much the y will rise by, because that's the vertical axis, compared to how much the x will run by, or how much you'll have to move side to side on the graph. I'm going to shrink that whiteboard now. We're going to focus on the first problem they give us. It says to graph this line using the slope and y-intercept. And the line, or the equation that they provide us, so they really mean graph the equation, and the equation is y equals 9x plus 1. Right away you should recognize this is in that y equals form that we see on our whiteboard, that slope-intercept form. So whatever the m is, whatever number is multiplied with x, that's going to represent our slope. So for this equation, I'm going to circle the slope. The slope is going to be 9. So let the marker tool load quickly, and I'm going to circle my slope of 9. And I'm going to put an underline underneath the y-intercept. The y-intercept is positive 1, what I've underlined. So the first thing I'm going to do is go ahead and plot that y-intercept. It's going to be right here. Every y-intercept, part of the reason we really focus on it, it's a quick way to build a graph, because the first point I want to plot a lot of times is wherever I am on the y-axis, or the y-intercept. So here, a y-intercept of positive 1, I can quickly plot that first point. I'm going to then use the slope, which is 9, and the slope is going to help me graph to a second point. So if the slope is 9, that's really a slope of 9 over 1, I'm going to travel up by 9 units. Not going to start at the origin, I start at the y-intercept. And so I travel up by 9 units, that gets me up to the 10, and I travel right by 1. So here you see I've started with a y-intercept of positive 1, and then I use the slope of 9 to travel up by 9 units and right by 1 unit. So to recap, and we're going to look at this on the whiteboard very quickly, if I want to build a graph, it's a 3-step process. 1, find slope and y-intercept. 2, the second thing we're always going to do is plot a point for the y-intercept. So as you saw there, I identified the slope and y-intercept. Second thing I did was plot a point for the y-intercept. And the third thing, I use that slope to find other points. So I'm going to use that slope to find other points. So hopefully that 3-step process works for you. Find the y-intercept and the slope, plot the y-intercept, and then use the slope to go find more points to finish the graph. So here it says graph this line using the slope and y-intercept, and the equation we're given is y equals x plus 4. The y-intercept, which I'm going to underline, is this positive 4. And then the slope, I couldn't underline it, so I'm going to highlight it. The y-intercept is this positive 4, and I'm going to plot that positive 4 y-intercept. And the slope, it's not really written there, but if they say y equals x plus 4, I know that coefficient of x is really a 1, and they just did not write that 1. This is really y equals 1x plus 4. So a slope of 1 means up by 1, right by 1. And you'll notice this line, once I plot that second point, after going up by 1 and right by 1, this line keeps following that process. Anywhere you look, it goes up by 1 unit and right by 1 unit. That's what that slope of 1x really represents. So again, new equation, y equals 1 over 9 multiplied with x plus 3. I'm going to first underline the y-intercept. That's this positive 3 right here. And I'm going to plot the y-intercept. That's step 2. Step 3, I'm going to use the slope to find other points. And here I notice the slope, the coefficient of x, is at 1/9. So I'm going to go back to this y-intercept, the positive 3, and use a slope of 1/9. I'm going to go up by 1 unit and travel right by 9 units. And when I travel up by 1, right by 9, and plot this point, now I've built a line with a slope of positive 1/9. Here we have the new equation, y equals 1/4 x plus 3. So our y-intercept, thing I'm underlining right now, is that positive 3. So I'll plot a point for the positive 3. And then also the slope is 1/4. The coefficient of x that I'm circling right now represents the slope. So I'm going to use that slope of 1/4 to go up by 1 and right by 4. And now I have the new line I need. Now, our new equation, we have a negatively sloped equation. It says y equals negative 8x plus 8. Our y-intercept is still positive. The y-intercept is represented by that positive 8 that I'm underlining right now. So I'm going to plot a y-intercept of positive 8. And the slope, which I'm going to circle now, is not a positive slope this time, but a negative 8. So our slope is really negative 8/1, which means y is going to lose 8 units. I'm going to track down by 8 units on the y-axis each time the x gains 1. So now we see this green line that starts with a y-intercept of 8, and then a slope of negative 8, meaning down by 8 each time it moves right by 1. We're going to provide one last example here, and then I think hopefully you should be in good shape to keep practicing on your own and figure out some of the tougher ones as you move towards the challenge zone. The y-intercept, which I'll underline, is at positive 7, so I first plot the y-intercept. And I also have identified or recognized for this linear equation that it has a slope of negative 1/6. Meaning I will return to that y-intercept of positive 7, my beginning point, my initial value. And the slope of negative 1/6 means y will lose 1. I will travel down 1 on this graph every time the x gains 6 units, or we move right by 6 units. So now this line started with a y-intercept of positive 7, and then it has a slope of negative 1/6. The y loses 1 every time the x gains 6 more. I hope that was helpful. Again, following this 3-step process of identifying slope and y-intercept, then plotting a point for the y-intercept, and finally using slope to find other points, I think is a tried and true method that should work to help you build these graphs. If you've got questions, read their explanations, and as always, feel free to send me an email, and I'm happy to jump on Zoom and help you out. Thank you for the hard work, and thanks for watching to the end of the video.